Welcome to another Qmi1500 tutorial session. This tutorial session is brought to you by Kali Tutors. If you haven't subscribed to our YouTube channel, please subscribe to get access to the latest videos the moment that we upload them. Okay, so just a word of caution, you might hear some chickens on the background. It's simply because I'm working from a farm and we've got a lot of chickens. Okay, so that aside, let us get straight to the question and try to solve it. Okay, so this problem comes from assignment 2 for the year 2022. I'll read the instructions and analyze the question, and then we work together to get the correct solution. Okay, so the question reads as follows. Peter borrows a sum of 12,850 rand at the beginning of a year with a certain simple interest rate. Okay, after 14 quarters in a different loan, he borrowed an extra sum of 3,273 rands, but at a simple interest half the former. At the end of 4 years, Peter paid a simple interest amount of 1,980 rands for both the loans. The original simple interest rate rounded to 2 decimal places is, okay, and then they give us the options. So basically this question tries to test your understanding of different timelines in relation to loans. Okay, so as you can see from the given instructions, Peter took 2 loans. Okay, took 2 loans and then at different times. You're supposed to use both loans to get your solution. Okay, so let's try to extract all the important information, but we need to take into account that we're referring to two different times. Okay, so for the first loan, what information are we given? They told us that he borrowed P, which is equals to 12,850 at the beginning of the year with a certain simple interest rate. So the interest rate we are not given, so instead of writing a value for the interest rate, we're going to say our interest rate is just R, therefore R is equals to R. Okay, and then how many years is this loan after how many years is this loan supposed to be repaid? Okay, so it's after 4 years, so we're gonna have time which is given in years as 4 years. Okay, so for the first loan, he borrows 12,850 at a simple interest rate that is not known for 4 years. Okay, so the second loan, remember he borrowed money after 14 months, so we need to take into account that he borrowed money after 14 months and then it ran until the end of the 4 years. When we talk about the 4 years, we're referring to the 4 years from the initial loan. So this simply means, let's see how many years is 14 months. Okay, 14 months is equals to, okay, let's divide this by if we were to divide this by 4, what will we get? Okay, if we divide this by 4, you're gonna get okay, why am I dividing by 4? Remember, each year has like 4 quarters, so if you divide 14 by 4, you get 3.5. So you get 3.5. That means it's 3.5 years. Okay, let me erase this. Okay, so we're trying to convert this to years. 14 months is equals to 3.5 years. So this simply means after 3.5 years of these 4 years, he went on to take another loan, right? So the second loan will only run for half a year, which is 6 months. So the time for the second the second loan, it's simply gonna be 1/2, okay, which is the same as 0.5 years. Okay, 1/2 is 0.5 years. Since he took that after 3.5 years, then it's gonna run for only half a year. Okay, so now we have T for the second loan. What is P? Our P is equals to 3,273. Okay, and then what about our interest, simple interest rate? Okay, the simple interest rate, we are told that the simple interest rate is actually half of this one. Since this one is R, half of R is gonna be 1/2 R. This is the same as 0.5 R. Okay, now I think we can calculate the interest for these two loans. Okay, so the interest that the bank will gain from this loan, it's gonna be I equals to P R T, which is given by, we have the values here. We have 850 multiply by R. So this is the R here. So instead of having this R, we're substituting R. So it's basically the same thing, multiplied by 4. Okay. So this is the interest that the bank is gonna gain from this loan, right? From issuing that loan. So this one, let's just multiply out and see what we get. Then it's 12,850 multiplied by 4. What do we get? We get 51,400. 51,400 R. Okay, so this is the interest that the bank is gonna get. Okay, so for the second loan, let's use that one. For the second loan, what is the interest? Okay, we're gonna use this second loan. We use the same equation, P R T equals to, okay, let's just say equals to here. Our P is 3,273 multiply by our R. Our R is 1/2 R, so it's gonna be 0.5 R. You multiply by half a year. Okay, multiply by 0.5. Okay, therefore the answer to this is gonna be, let me just multiply out. Okay, 3,273 multiplied by 0.5 multiplied by 0.5, then we get 8,1,8,25. Okay, R. Okay, so now we have the interest from the first loan and the second loan. As you can notice, both interests are calculated in terms of R, right? So we have this information now. What are we supposed to do with this information? If you go back to the instruction or the statement, they told us that Peter paid a simple interest amount of 1,980 for both the loans. This simply means the interest from both loans, which is, let's say this is I1 and then this is I2. Okay, the interest, the total interest from both the loans, which is I total, equals to I1. Okay, I1 plus plus I2. Something is wrong with this mouse. Okay, I2. Okay, then we know we have the answer to I1 and I2. This is I1 and then this is I2. So we just substitute everything here. Okay, so this is the chickens on the background are disturbing, but anyways, let's continue. This is 1,980 equals to 5,1,400 400, okay, plus we're just substituting the values that we just calculated previously. Okay, then this one, as you can see, everything is calculated in terms of R. So these two, this one and this one are like terms. If they are like terms, we can simply add them. So we're gonna add the 51,400 and the 818.25 R. Okay, so let's just do that. We're gonna get here, let me use my calculator, this one plus 51,400, then we're gonna get 1,980 is equals to 218.25 R. Okay, so in order for us to determine R, let me just take this and move it to the top, right? I'm taking that and moving it all the way to the top. So now we have this one, 850 or yeah, 1,908 equals to this is 5212.25 R. So now to determine R, we're simply gonna divide both sides by the coefficient of R here. This is 52,218.25. We're dividing both sides, and even here we're dividing by the same value, 218.25. Okay, then the answer to this will be R is on this side, so this will cancel this, and then we are only left with 1,980 divided by 52,218.25. okay, so this is 0.0379. okay, remember to determine the interest rate is normally expressed in terms of percentages, so we'll simply multiply this by 100. okay, then you multiply by 100, then your R will be equals to 3.79%. okay, okay. So we're done with the first question, and then the answer to this is actually D. Okay, so once we're done with that, let us move on to the second question. Okay, let us move on to the second question. Okay, so the second question deals with a system of linear equations. You are given two linear equations, and then they want you to determine the point where these two linear equations intersect. So when you're dealing with a system of linear equations, okay, for example, you're gonna have, okay, let's say you have two graphs, graph 1 and graph, okay, and graph 2. The point where these two graphs meets, okay, is the solution to that system of linear equations. So let's say this was our Cartesian coordinate system. Okay, this is the Cartesian, this is our Cartesian plane and stuff like that. So this is your x-axis and this is your y-axis. This point here, this point where the two graphs intersect, that's what we're looking for. Okay, x and y. We're trying to determine that point. So if you have two equations and you have two unknowns, it's simple. You can use Maltner's equations to determine the point where these two lines actually meet. Okay, so that's exactly what we're gonna do in this tutorial session. Let me change back to red. Okay, so we're gonna use simultaneous equations to solve this. So when you're doing simultaneous equation, you can take any of these two graphs and make one variable the subject of the formula, and then use that, take that and substitute on the other equation. So what I'm gonna do, I'm gonna take the second equation because x doesn't have a coefficient, and then make x the subject of the formula. Then this will become, I'm gonna take this, this will become plus 2y. So I took this y to this side here, and then when you do that, the 2y changes the sign, and instead of being negative, now it becomes positive. And then after you've created, this is our equation, let's say this is our equation 1. Then after you've created equation 1, you take equation 1 and substitute into equation 2. So our equation 2 is this one here. So we're gonna have, this one is like this, 3x plus 5y equals to minus 11. So where there is x, we will substitute this, because we know that x is equals to 11 plus 2y. And then once we do that, we'll only have one unknown, which is gonna be x. We're gonna, okay, so let's express x in terms of y. This is gonna be 3, and then here, instead of having x, we put this, since we know that x is equals to 11 plus 2y, I mean. Okay, 11 plus 2y, then we move this down, 5y equals to minus 11. So here we did a substitution. We substituted equation 1 into equation 2. Then we can now solve this. Okay, so this becomes 3 times 11, that's gonna be the, oh sorry, then okay, let me do it here. 3 times 11, 3 times 11, that will give us 33. Okay, that will give us 33. 3 times 11 is 33, and 3 times 2y, that is positive 6y, and then this, we're not doing anything to that, so we're gonna write it as it is, equals to minus 11. Okay, so let's group like terms. Okay, we'll have constants in one side and terms with the variable y on one side. So we're going to take this 33 and move it to the other side. Okay, then it will change the sign and become minus 33. So we're going to have minus 11 minus 33. Okay, so on this other side, we're going to have 6y plus 5y. Okay, so these are like terms, then we can simply add them. 5 plus 6, then you get what? You get 11y. Okay, so this is 6y plus 5y, you get 11y, which is equals to minus 33. Minus 33 and minus 11 are the same as having something like this, 11 plus 33. Okay, so this gives you minus, these two will give you 44, and the sign here is minus. Then you have minus 44. Okay, to solve for y, we need to divide by 11, so that this will cancel this, and then we need to do that on both sides. Okay, divide by 11, 44 minus 44 divide by 11 gives us what? Gives us minus 4. Okay, so now we know the value of y here. This is minus 4, but minus 4 is not like on the top half of this this Cartesian I mean on the top half of the minus 4 is not above the what the x is. Anyways, this was just a typical example, so it's basically somewhere here. The minus 4 is somewhere here, so don't stress too much about that. Okay, so yeah, so once you have your y, you can solve for x. Remember, we do have an expression for x. You can use this one or this one, it doesn't really matter. They both give you the same answer. So we're gonna take this minus 4 and substitute it in equation 1. Therefore x will be equals to equation 1, x equals to 11 plus 2y. Okay, but we know that y is equals to minus 4. Therefore we're gonna have 2 minus 4, and then this is equals to 11. So 2 times minus 4 gives us minus 8. Then we have something like this. Then 11 minus 8, we have 3. Okay, so x is equals to 3. So we're gonna have this point here. This is 3 and minus 4. Okay, so this is actually the answer that we were looking for, and then you can go to your options and pick this one. Okay, so yeah, we're done with this tutorial session. So for those of you who are interested in joining our online classes, please go to qmi1500 in that space we are able to cover all the questions and discuss and take questions from students, and if there's someone struggling, we give them extra lessons so that they end up grasping whatever we are teaching them. Okay, thank you for watching this video.